Hi folks, welcome to another episode of Fix My Kubernetes Cluster. We will follow the same pattern, so I'm not wasting time there. I don't have any cluster with me right now, so let's create a new cluster with an issue. Yeah, the cluster is created, the nodes are ready, the namespace is ready, it is creating some Nginx pods. Yeah, Nginx pod is met with the condition ready, so probably it started running. So we have a service created for it, we have an utils deployment created for to debug things. Yeah, utils also started running. We are seeing that working service is working. We are able to get some response from Nginx. So issue has been created. Now we created another service called not working service. If we try to reach the not working service, we are getting an connection timeout after 3 seconds. Let's try to fix it. So again, let's try to take this command and see if working service is running. We are able to reach. No, we are getting timeout. Not working service is not working. Let's see at least if the working service which was previously getting response, is it working now? Okay, it is working now. Only the not working service, we are not getting any data. It is getting a timeout. Okay, very similar to last session, right? We can see if, let's try to see the service. Okay, a not working service. Let's try to describe it. If you see here, we have an source endpoint and we have an endpoints also, which is pointing to 0.5 endpoint, which means I don't know. We have this endpoint. Maybe this we can check if this pod is running fine. If the pod is running fine, it should be able to get the response. Let's check the working service describe. If you see, the working service is also pointing to the same IP, and we are able to get response from working service, which means in this IP 10.244.05. The Nginx is running and it is able to serve request. Now, if we try to once again try working service, right, we are able to get the data. But the not working service is also pointing to the same endpoint, but it is not getting the data. So it is not problem with this IP or this port. There is something else is the problem, right? So now, which is the component who is responsible for doing this mapping between this SVC service? So if you see here, the one difference between these two services is the IP of this, because each one is a different IP. It is having an IP 1096.74.251. This is having 1096.221.243. So each are having different source IP for this SVC, but the destination points to the same. So the maybe yeah, it is an connection timeout. It is not DNS resolution, which means DNS resolution is also happening fine. So which means this source IP to destination is not happening. So in Kubernetes, which component is responsible for doing this source to destination mapping for the SVC? Let's see. So in this case, it is kube proxy. Let's see if it is running fine. If we can see any logs of that one. So let's do kubectl get pods in the kube system namespace. If we see here, we have core DNS, the kind net, which is the CNI component, but we don't see any kube proxy component running. So kube proxy will run as a daemon set. Let's see. But we don't see kube proxy at all here. So probably the kube proxy has been deleted or has been removed by mistake. Let's bring it back. So I have this kubeproxy.yaml file, which is a daemon set, which is going to run the kube proxy. Let's apply this. Yeah, before applying, right, let's understand how this kube proxy is basically doing this mapping. So let me docker ps, let's exec into the container. I mean, in the control plane node. So 2df bash. Okay, we are inside the control plane machine, right? This is where all these parts are running. Now, from the utils pod, we are able to reach the Nginx via one service, but the same Nginx we are not able to reach from the utils pod with the another IP, right? The not working IP, we are not able to reach it. Let's see. Okay, so we know kube proxy is going to, if we bring the kube proxy, maybe it will fix the problem. It should work. But let's see what kind of the rules the kubeproxy made so that it is working for working -service, right? So we have this IP table rules. We can print the list of IP table rules that is there, which is manipulated by the kubeproxy. So let me run this command called IP tables, get the list of pre-routing rules present in this machine. If you see here, we have this routing rule saying, okay, for all Kubernetes service, this is the rules. Now, let's see all the kube services. If we see here, if we have rules for 10.96.0.10. If you remember, it is nothing but the kube DNS SVC, which will go to the core DNS that is running. Then we have one rule for 10.96.0.1. Let's do SVC in another tab, kubectl get SVC -a. If you see what is this 10.96.0.1, it is a service called Kubernetes, which will basically point to the API server that it is running. Yeah, and there is a rule for 74.251, which is nothing but the working service. So we have all these manipulation rules for this IP table rules for the working service, all these things, but not for the not working service. Maybe because the kubeproxy is not running now, it doesn't have the rules. Maybe once we bring kubeproxy back, maybe these rules may get added. Let's understand this rule a little bit, right? Let's take this rule. If you see here, we have this rule basically from the source anywhere, and the destination is this one. We can try to see the details of this service, what it says. Let me run the same thing. And here we say the label is this one. Here, if you see, if the source is this one, 10.96 this one, then it is going to the destination called 10.244.0.5. Let's see what is running in this 10.244.0.5. Let me do kubectl get pods -a. Oh, I have to do -void. Let me clear the screen. Yeah, if you see here, it is nothing but the Nginx. So this is how, when we try to reach any SVC, first the SVC's name will be resolved to the IP. The working service will be resolved to this IP. Then this IP, if we try to hit it, this IP will be changed by the IP rules to this IP. That is how we are able to use the service IP to reach the different pods. Now let's bring the kubeproxy in. Let's do kubectl apply -f kubeproxy. The kubeproxy daemon set has been created. Let's get the pods. Okay. If we see now, the kubeproxy started running because it's a daemon set and we have only one node. It started running in this the single node. Let's see the rules now. Let's see the rules for the kube services. Now let's in another tab, let's do the get service. If you see for the not working service 243, we got the rule added. Let's inspect the rule before we try to test using the curl command. Now, yeah, now if you see the same IP, the destination is going to the Nginx pod cluster IP. So now if I do the curl command for the not working, it should be able to reach it, right? So yeah, so this is how the IP table rules are manipulated by the kubeproxy, by using the service IP, we are able to reach the cluster IP or the pod IP. For example, right, let's inspect the core DNS, which is having, in our case, right, let's do the kubectl get pods -a and -void. We have multiple instances of, basically 2 instances of core DNS, right? 3 and 2. Let's see how the rule looks like for the core DNS, which is of IP 10. So I will go and copy this. So in this case, if you see that there are 2 destinations. One is to the 0.2 and another is the 0.3. Because we have 2 replicas running, we have 2 rules. And with the probability of 50% to this IP and 50% to this IP. So similarly, we have more replicas. Using a single IP, we should be able to reach different replicas based on the IP table routing that happens. So basically, the kubeproxy is the component which takes care of doing this IP table manipulation for us, which helps from the SVC IP to the pod IP. So if you want to learn more, about this one, you can go to this Understand Kubernetes Networking Services. It's it's on 2017 Medium blog, but it is super detailed one. It will be very helpful about how these rules are getting created, how kubeproxy is creating it, and things like that. Let me quickly show you the script which we use to create the cluster with an issue, because we're using the scripting, right? We will have some learning from there also. So if you see, we are using the kind to create the cluster, and we are waiting for all the nodes to be ready. Then we are waiting for the namespace to be ready. So here we are creating that pod and the SVC, and here we are basically using the utils pod, which we use to debug things. So here, basically, when we do create issue, we basically took the copy of the kubeproxy and deleted the daemon set. So because we deleted the daemon set, there are no proxies running, kubeproxy running. So which means after that we created an not working SVC. So the new IP table rules are not manipulated, because of which not working SVC is not working. But the SVC, working SVC was created way before we delete the kubeproxy. So before deleting itself, the kubeproxy might have, so kubeproxy actually have created the IP table rules for this working service. That's why we are able to, even after bringing down the daemon set, we are able to reach the working service, but not this one. Yeah. After bringing back this daemon set, all these IP table rules are happening, and we are able to reach it. If you like this video and if you learn something, like this video and add some comments in this, so that it will be encouraging for me to do more contents like this. Thank you.